Okay, so let's move on to the next topic here, and this is going to be on functions with array outputs. And what we're concerned about and trying to accomplish is that we have an array that we want to get outside of the function scope. And as we'll see, it's not really a clear-cut way in how to do that. And there's a lot of kind of nuance and some tricky concepts that are kind of mixed in here. All right. Now let's do this in the context of an example. So let's imagine what we have here is we want to build an absolute value function, but we want to do it in the context of an absolute value function that works over an array. Okay, so let's imagine we have an array that we'll just make it something kind of small, maybe 5 elements, and we'll put some data in here, right? Okay, and let's imagine this is our original array. Okay, and then let's our goal here is that we have an original array, and we want to have our result or our output, okay, to be the absolute value of each element in the array. Okay, so that if it's positive, it's going to stay the same. If it's negative, it's going to become positive. Okay, now a couple things to note, right? If we do it this way, right? The idea is the goal, right? If we're treating functions like a black box, is the goal is that we want to leave the original data, okay, unchanged. Okay, we want to leave that unchanged, okay, and we want to be able to return the output. So we want this is to be the data that we've returned. Okay. Now, as we're going to see, is this is not as straightforward as it may sound to do this. And one of the best ways of doing it relies on a concept that we're not going to be able to get to till later in the class because it's a fairly difficult concept related to different memory regions. But let's just, that aside, let's think about what the function header would ideally look like in this case. Okay, what would the function header ideally look like? And in that case, right, the ideal situation would be that we have an array as an output, okay, and that we're getting, we call it something like, I don't know, get absolute value, and that we're passing in our original array, okay, and this, as we've seen before, we need to have the size, okay. So that would be the ideal function header, right? Is we've got our, and actually I should include one thing here, as we saw in a previous video, we should also make this a constant, right? So that to really force the fact that we can't change this up here. All right. Now that would be the ideal case is to do that. And as we're going to see, it's not as clear cut to make it work that way. So let's take a look at this example here and see why this this is a common error and there's an issue with this. Now, small syntactical detail that I don't want to get hung up on, I'm just going to point out here, is because arrays are pointers, I've got this weird thing here where we're having this asterisk. I want you to think of it at this point as that we're just returning the array, which is a pointer, and you could think of it as these opening curly brackets. Okay. Now it actually won't compile if you do that. We'll go deeper into why later on, but for illustrative purposes, you can kind of conceptually think of it as that for now. Okay. Now, and then same down here, right? We're returning an array. An array is really a pointer. We're going to see how the syntax really looks like that. However, you could think of it right now as being, right, that we're returning a, open and curly brackets, okay? The open and closing square brackets, aka returning an array. All right, so let's see why there's a problem with this example. Okay, now I'm going to draw out what's going on in memory again. We've got our main scope, main function scope. And in the main function scope, we've got things like size. And we also have this, we have our array A, okay, points to a location that's storing an array. 5, -3, 8, -12, and 4. Okay. And then we also have our array 2, our results here. Okay, we'll come back to where that points later on. Now, when this is called, right, the absolute value function, so we have our scope of this function. And, oops. What we're going to see here, okay, is that we have a read-only connection, right? Array is a constant. Array is a constant. So we're going to have a read-only connection here where we point to the start of that array. Read-only because it's constant. Okay. And we are going to we declare a new array here. With the proper size. And as we see, we've got this logic in here that, you know, if the array element is positive, we just copy it over. Okay. So as we run through the loop, we're going to say, well, 5 is positive. We're going to just leave that alone. 3 is negative. It becomes, we're going to take the negative of the negative, right? 8, 12 is going to become positive, and then 4. Okay, so we get, that's our correct result down here. Now the new array points to that. Okay. Now, when we return here, new array, what we're effectively doing, right, is we're setting this array pointer down here, right? This array points to, right? All arrays are pointers. They point to location and memory where the array is stored. What that's doing, okay, is array 2 points to where the new array points to. Okay, now that seems like that would be fine, right? However, right, remember what happens when this function returns, right? When the absolute value function returns. When that returns, all the data here is freed. All the data there is freed. You think of it as deleted. It's a little bit more complicated than that, but effectively it's deleted. Okay. So this data is no longer, this location memory is no longer valid to be used. And so we can't do that, right? And it has to do with the fact that the scope of new array is limited in this absolute value function scope, which disappears as soon as the function is returned, right? Now you'll get, if you do make this error, I want to point out a way that you can kind of recognize it. If you forget, it's an easy thing to forget. This is a nuanced thing. You will get a warning, a compiler warning, right? And it says function returns address of local variable. Now in this case, that's a pretty good warning. It even tells me, hey, there's an issue right here related to this variable being returned, right? It gave me a very meaningful warning. Take warnings seriously. Take them seriously. Think about what they mean, right? Returns address of local variable, right? Effectively, right? What is that saying? Hey, we're returning an address that's local to this function scope, all right? And we're trying to return it, and that address is going to be free. That location in memory is not available anymore, okay? So that's a problem, right? That's a problem. So now let's look at how some different options for how we can fix this, okay? Let's look at, here's one option, right? One option is just to change the original data. Okay, so we look at this example here. What that's doing is saying, well, okay, what if we just did the following? What if we just said, hey, I'm not going to make this input constant, and what we'll do is we'll just change the original data. Now that will work, right? Because we're going to go in here and say, we've got our main function scope. And we're going to do something like this, where we got size is 5. We've got our original A. A points to, okay, 5, -3, 8, -12, and 4. Okay. And then in the absolute value scope, okay, we also have size 5, pass by value for size, right? And then we have array points to the original, right? Points to the original, so that when we do the absolute value, right, these ones, those elements are going to be overwritten, right, with the positive version of it. Okay. Now that, and then so when this function is returns, right, the original data has been edited. All right, so our result is now in this array A. Now that will work. That will work. The reason it's not really ideal is we want to treat functions like a black box. We want to treat them like data comes in. We have some logic and data comes out. We have kind of a weird way in which, in this case, the data's coming in, right? It's doing some logic, and then we're like have this kind of thing where we're changing the original data. It's kind of a weird way to look at it. It will work though, right? It will work. Okay. Another option that will also work, right, that has the advantage of not changing the original data, is to pass in an array that we want to have store the result. Okay, so notice the function header here looks different. I have an additional parameter. I have a second array coming in. Okay, the original, right, the original is constant, can't be changed. The new array is where I want the result to be stored. Okay, let's trace this out. Let's see what's going on here. We have main. Okay. Size is 5. Okay, we have our original A. Okay, storing 5, -3, 8, -12, and 4. And then we're going to also have a result, okay, that we're going to store as it's an array. And I make space for it, right, for 5 elements. Okay. Now notice it's in the main scope, right? It's in the main scope. Okay, and then for our absolute value scope, okay, we have array, we have new array, okay, and we have size, okay. The array is the original, right? That opens a read-only access pointing to the original array. A new array points here, and that has write access, right? Because there's no constant listed here. Okay. So when we now go through the logic, okay, and then when the absolute value function returns, okay, this data is freed. Okay. However, we do still have our result here in a valid location. So, right, now again, that also still looks weird. It's not really ideal. We think of our black box. We're now kind of having something like this where we have some data coming in. We also have some data kind of coming in and out, right? We're passing in result as an input, but it's also an output, right? And then we have size. We're kind of doing something like this. Not really the ideal situation where you want to have data coming in, do some logic, right? And then data coming out, okay? So there is a way, as you might kind of guess, there is a way to do that. There's a way that we can follow this type of function header, this interface, okay, where we have the array coming in, right? We have the size coming in, right? And we have an output coming out, right? This here, you can think of this as our array pointer, right? We'll look more deeply at that syntax later on, okay? There is a way to get that to work. There is a way to do that and to follow that interface. However, we're not ready to go into that yet. That is actually a fairly complex topic. It requires learning something about some memory regions, particularly something called the heap memory region. And that's going to be continued at a later part in the course where we talk about some of the different memory regions and how they work and some of the advantages and disadvantages of each. And when we get to that, we will see at a other point of how we can actually follow this type of function header for these types of problems. But we're not ready yet, and so we will save that for another day.